Welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome you to a special interview recorded by Fred Schenkelberg in 2016 at the Rams Conference in Orlando, Florida. Fred's guest was Dr. Joel Nachlas, Associate Professor Emeritus of Industrial and Systems Engineering at Virginia Tech University. Dr. Nachlas has been at Virginia Tech since 1974. He's a senior member of the Institute of Industrial Engineers and a fellow at the American Society for Quality. Dr. Nachlas was the recipient of the IIE William Golomsky Award in 2004. His research has been the topic of a number of technical publications over his long career. Fred spoke with Dr. Nachlas about his work as the editor of the Reliability and Maintainability Symposium proceedings and the recent publication of the second edition of his book, Reliability Engineering, Probabilistic Models and Maintenance Methods, now available from CRC Press. Let's join Fred's interview with Dr. Joel Nachlas.
Welcome to Dare to Know. This is Fred Schenkelberg, and I'm very honored to be talking to Joel Nachlas. And I know, Joel, you've been in reliability for many years and influential in a number of different publications and documents and so on. But I know you from being the RAMS, the Reliability and Maintainability Symposium editor, essentially. And as you were just mentioning, we'll let you explain it. What's your primary role as the editor of this publication?
Well, I took over the editorial responsibilities in about 2001 from the previous editor, who was Ralph Evans.
Right.
And
now, for the audience, though, Ralph Evans, he was the editor of, I think, Technometrics, if I remember right, and he had like a column in the front of that.
Actually, he was the editor-in-chief for the IEEE Transactional Reliability.
That's the one I'm thinking of. But he had such a wonderful column and insights.
He led most issues with an editorial column that related to the balance between the practice and the theory of reliability, and he always had a lot of very good insights.
He did, yeah. And so you took over from him about 2001. Now, you'd known Ralph and been involved with this process for a while.
That's correct.
Okay.
I've been giving papers and doing research in reliability for quite a long time at that point.
Okay.
As I see it, and as I interpret Ralph's model of behavior for the editor, what I try to do is, first of all, assure compliance with IEEE format and presentation quality requirements.
Okay.
In addition to that, I think that it's important for the editor to read the papers and in a sense, look for problems, and if there are any, try and identify them back to the authors and give the authors an opportunity to make corrections and things like that. In the process, I have to say that sometimes I make some editorial improvements, sometimes in the case of grammar. I'm actually rather well known for being a bit of a stickler with the grammar.
Yeah, well, have you seen any improvement with the use of like Grammarly and some of the editorial tools?
I do think especially the spell checkers have made a huge improvement.
Okay, and I apologize for my early papers over to you because I knew they were a pain. And I have gotten those notes from you.
Yeah, and I also, when I can, if I see a technical error, and they occur, or sometimes an author hasn't really made a technical error, but they've made a mistake in the way they've represented the work, and I'm talking specifically in the mathematics of it,
right,
in the equations and so forth.
Right.
If it's obvious what the correction should be, I make it to the equations, and in some cases, if it's not completely obvious, I'll ask the authors to make corrections to the equations. So the end result is that I try to arrive to the point of having a set of papers that go into a published document that are relatively uniform in format, that are, let us say, as high in quality of content as I can encourage them to be without
Right.
actually being the authors.
Right.
And that are appropriate for communication to the technical community, especially through the IEEE's publication process.
Okay. And I know that's one of the draws for people publishing here, is because it does get published in a journal-like document. It's the proceedings, but it gets listed alongside other technical papers. When I'm looking at table of contents for the different journals, this conference publishes as many or more papers per year.
Well, the number of papers that are included each year is not a decision that I make.
Right.
Okay. And whoever happens to be the chair of the meeting that particular year, and probably in collaboration with the program chair, they make this decision on how many papers to include. And over the years, it's been increasing a bit.
Mm-hmm.
I think I'm not sure we've got the right balance in the terms of the total volume, because what you'd like to do is get all the good ones and no more.
Well,
and
that's
they do
different.
pretty well with that.
Yeah, and that's a moving target all the time.
Yes, it is.
I'm sure it is.
Yes, it is.
Right. So now, one of the things Ralph would do is comment on the trends that were happening in the industry and those kinds of things. Have you
Right.
seen, you've been doing this, do quick math here, what, 16 years, 17 years, 16,
Well,
15
my
years?
editorial roles in that respect, yeah.
All right,
And
so-
I've been involved in the discipline for considerably longer than that. And I have seen some evolutions, and especially now, I mean, if you look at what's being published and what people are doing, as with any technical field, there's definitely been advances and improvements and new domains of study. Okay. Certainly the condition-based maintenance area is one that wasn't even discussed 15 years ago, really.
No, and I think it existed. It's gotten a name now, and I don't think it has its own conference yet, so maybe we'll get it here.
I don't know. I think it's appropriate here.
Well, describe content or condition-based maintenance a little bit, because
Well, the basic principle is that you'd like to devise means by which you can observe descriptors of the state of a device that indicate the degree to which it is weakened or deteriorated, so that you can make repair or corrections prior to the failure occurring.
Right.
And the advantage is that the idea is that this will be adaptive in real time, rather than historically what we've had is scheduled maintenance of one sort or another.
That's right, or you wait till it fails.
Or you wait till failure, which for some equipment is not necessarily the wrong thing to do.
Right.
But the idea with the prognostics or condition-based maintenance is that if you can identify an indicator variable which gives you some insight into the actual condition or the state of the device, and that you can interpret that sufficiently well to make intelligent, adaptive maintenance decisions, you should be able to save money and reduce failures.
That's
and
right.
I think the concept, very good. Success with it has been mixed, but there's clearly evidence of cases in which there have been some very important successes. And I think it's the sort of thing that's just one of the many, I think, new evolutions in reliability that are important and that make a contribution to our, if you will, to our society and to our equipment.
Well, and that's a big part of what we do as reliability engineers. Many people have told me in these interviews that it's making a product better, or a device or system better. And oftentimes that means fewer failures, but not always. It's the right balance in all those realms. And so, yes, if in an industrial plant we can project when a motor is going to fail, and we can off-shift, we can replace it just in time, so we get the value out of that motor.
Of course.
It's a win for everybody.
Clearly that's the case.
Yeah. So that's one trend. Are you seeing much with the more buzzword type stuff? We're hearing drones and autonomous vehicles and Internet of Things, and is that? Well,
there's a couple of ways you can look at that, and my view is those are just new areas of application.
Okay.
Okay. The fundamentals of reliability would start with the idea of making designs better,
right,
making equipment so that it fails less,
right,
figuring out ways to anticipate failures and therefore avoid them, making things safer. That applies to, and I think one of the reasons the discipline continues to be important is it applies in all types of equipment, and not just in equipment, but in systems of systems, communications and transportation systems,
That's right.
for example. Or,
That's right.
I mean, you could go, the list you could go for a long time talking about weather forecasting systems or
aircraft control systems,
yeah,
or the pool maintenance guys down here,
right.
and their systems.
There's a lot of applications where it's really important, but you never see them. For example, think about climate control systems for shopping malls.
Right.
Okay, nobody ever talks or thinks about that.
Well, except for the plant maintenance
Right.
folks there.
Well, and the folks that are designing the equipment that are going on the roofs of those centers and things
That's
like
right.
that. And especially if you think about, I mean, you know, you really can go on and on and on. Look at what's happening in the construction industry with taller buildings, okay, or higher density occupation in cities, or more sophisticated transportation systems, especially as populations grow and you have to provide better transportation options. All of these are new domains for a discipline that has an important role to play.
Okay. Well, this might not be a fair question, but do we have enough trained reliability engineers to meet the needs? Are we, as a discipline, educated for what we're being asked to do?
I really don't think we do have, well, there's two parts to that. I don't think we have a sufficiently large cadre of specialists in the discipline. And I also don't think we have enough centers of education or training for the discipline. There are just a couple of universities or schools that have more than one person working in that area.
That's right. Yeah,
Okay?
Maryland, Tennessee, and
Well,
Arizona used to.
Arkansas's
got a program.
Rutgers. But most schools, if you look, for example, at the folks that are here at the conference who are recognized experts, they, whether they be in industry or in university, they tend to be the only person in their organization.
And they have a couple of classes, and they might get some influence in a couple other courses, and
Right.
it's not a program per se. I think the last tally I did, there was like 15 or 16 different PhD, advanced degree programs around the world. And there's a cluster in England,
Right.
a couple in Asia.
Well, you have Eindhoven in Holland.
Oh no, I don't know
Okay,
about that one.
you have some very good reliability people at Grenoble and Troyes and Angers in France.
Okay, well, I'll have to get a list from you.
There are, but once again, it's small pockets. You have, in fact, I don't even know, Tony Bendel in the UK used to be one of their real icons, and of course John Andrews, who comes to the symposium here at Nottingham. But I think he's almost, as I say, one of these people. He's the one person there.
Right.
He's a strong presence, and so are some of these other folks. But there are, for example, in Grenoble and Troyes, you have 2 or 3, 4 people.
Okay.
And in Eindhoven, I don't know who. I think Robert Decker, and I think he's got 1 or 2 colleagues working with him. We used to have in Sweden. You had at KTH. You had. I'm an old man. I'm losing some of these names, but one of the real stars. I'm sorry, I'm losing that name.
It'll come.
He was at Linköping, and then he went over to KTH, and he collaborated a lot with Ben Clefshow up at Luleå,
Okay.
for example.
I've heard of Luleå. Do they still have a program going?
I don't know how much they're doing. One of the important PhD students that came out of that program was Arun Kumar, and he is still in Sweden and running a group, but I'm not sure whether he's at Luleå or down at KTH, and he's given papers here.
Okay. So, I mean, university is one way, an advanced degree is one way to get that. A good number of people here at the conference and around the world are mechanical engineers or electrical engineers or have some science background, but not manufacturing engineers. And the conference becomes a primary way for them to become their professional development path.
That points back to basically what I'm saying is there's a lot of very sharp engineers
Right.
who, if they had an opportunity as part of their undergraduate education or graduate education to pursue reliability subjects, they would. When they ultimately graduate and they haven't had that opportunity, and perhaps later on arrive in a responsibility where reliability, especially if they're focused in design or something like
Right.
that, then to come to something like the Symposium here is the key opportunity for them to acquire access to the technologies that we use.
And besides the well-written and formatted papers, and beyond spell check, I do remember that. What got you into reliability engineering?
I guess the path for me was that I started my career with an emphasis on, and remember as a university person your focus is theoretical,
Right.
and I was working in applications of probability.
Okay.
And I also had focused even in my undergraduate year on quality control and applied statistics.
Okay.
And as a matter of fact, in my undergraduate years at university, the course that captured me was the quality control course given by Atchison Duncan.
That name sounds familiar.
And he was one of the long-term important names in quality control.
In quality control being process capability and control charts and associated
Specifically,
pieces
what we
of it.
now call SPC, control charts
Right.
and sampling and things like that.
Right,
yes.
that's why I think, how come he didn't get his name attached to any of these charts? It's a Schuhart chart.
Well,
not Duncan.
Schuhart was in the 20s, and Duncan was actually very well known. And there's a Duncan test for homogeneity and things like that.
There's a non-parametric test,
Yes.
if I remember right, yeah.
But he was always a well-recognized expert in quality control.
Okay.
But independent of that, I mean, not because of that so much as because of the course that I had from him, it lit my interests, as it were. And so then as I evolved, a lot of my earliest work was really focused in quality, and then for me it was just a natural evolution to expand quality, reliability, and you got into the argument, is reliability part of quality or is quality part of reliability?
That's right, yeah, I hear that a lot.
But in my opinion, it doesn't really matter. The point is the two are complementary or common domains, if you will, and so the evolution for me was natural.
Okay.
And then, frankly, the thing that came for me a bit later was the interest in maintenance and maintenance planning. And so I evolved from, if you will, studying failure processes and design improvement to then moving further on and into the maintenance planning and so
Well,
on.
in some industries, that's where the money is. It's the logistics train and the maintenance packages that come with some of the systems that are deployed in factories or around the world can be orders of magnitude more expensive than the original purchase price.
Right. Well, there again, I had the good luck to be at Virginia Tech and have a lot of interaction with Ben Blanchard, who was one of the guys that really first and for a long time successfully promulgated the recognition of the fact that in your design process you're committing yourself to the life cycle costs of your deployed equipment and systems. And he and I spent lots of hours talking about that.
Okay. Now, the life cycle costs is, I've run into some reliability engineers that look at that, well, that's for the MBAs, that's for the project manager, or the systems engineers.
I certainly wouldn't agree with that.
All right. So
I think the point is when you make a design decision that ultimately determines what the maintenance path is going to be like and what the spare parts requirements are going to be, and you can just go ahead and make your list from there. You can see that as you're making design decisions, you are to a very large extent determining what expenses are going to be incurred in not just the fabrication, but in the support of that equipment.
So a few years ago, I ran into a company that they wanted to, the military that they sold these units for, these fancy boxes, detector boxes of some sort, which they never really told me what they did. It was an electronics box. And they said, the Army says, or the Air Force said, we have to improve the reliability. The failure rate's too high. And they did no testing. They did, I've turned it on and make sure it worked, but they didn't make any prototypes. They didn't do any design for reliability, even derating, which just wasn't a concept they used. And so we started talking about, you need to do this. The program manager says, no, wait a second, you don't understand. We don't make money on the original product. We make money fixing it. So why do we want to make it not fail?
Well, the issue is that if you don't make one that fails less, somebody else will.
That's right.
Okay.
Yeah.
So if you're concerned about your market position, then you want to make it seems to me fairly logic, you want to make as good a product as you can make.
That's right. Well, is there any movement on that? I mean, the F-35 certainly has been a poster child for how not to do a procurement program. But has there been progress that you've seen in getting that message across that you need to design in reliability?
I honestly think that we've had a long time of interest and emphasis on that, but like anything else, especially when you're talking about a military procurement process, there's an awful lot of other factors that influence how those work.
Well, even a cell phone, right? Or a laptop. And we're sitting here with the laptops and cell phones and watches and stuff, and time to market might be the dominant factor.
Right.
Not necessarily feature set, but cost is always a factor. There's always constraints.
Yeah.
Right. So, I mean, you've read thousands of these papers. You've written dozens and dozens yourself.
Yeah.
Do you have any books out? I should ask that too.
Actually, I have written 3 books,
Okay.
one of which deals with reliability and maintenance, and that's the one of which I am most proud.
Okay.
And the second edition of that book came out this December.
Oh, okay.
And I am I'm not one advertising, but I am especially pleased with that because I think I've done a very comprehensive treatment of maintenance planning.
Okay.
All the different sorts of maintenance plans you can have as determined by the type of equipment you have and things like that. Of course, the focus is on the mathematics of it or the probability of it. But I'm especially pleased with the way it's come
Okay,
out.
we'll hook those up in the show notes for the course. I mean, you could obviously just search for you on Amazon, I'm sure, or your favorite bookstore.
I suppose, yeah. It came out, literally the second edition just came out in December. So.
All right, we'll have to track down a copy and get an autographed copy while we're sitting here.
Okay.
See how quickly I can deliver one.
All right.
See if I can do that. Maybe next year, I'll bring it next year.
There you go.
All right. On your experience and all of these papers you've seen, do you have any advice for a new reliability engineer that's joining our ranks? What should they do next?
Well, I don't. That's a really tough question. I mean, depending upon in which kind of domain they're working, whether they're in academics or in industry, I hope. And I don't think it's necessarily the case, but I hope that people that are working in our field are always looking for ways to improve it.
Right.
Not just to improve their products, but to improve the technology that we use to improve their products.
Okay.
Or to improve what we do to improve systems. As I say, sometimes there are say logistical systems or management systems or other things like that can be improved, and that can be improved by the application of things we know about reliability or things that we can now create that make our reliability technology better.
Yeah, I'll add to that is that when you come up with that innovation or that new concept or you get a good application, it's a perfect paper for RAMs.
Absolutely. Yeah, this is the place to communicate that information and to talk with people about it and get, frankly, you get more rapid feedback.
That's right.
You're going to have people, especially if people disagree with you.
That's right. Yeah, it's you do get feedback, and if you're lucky enough to give your paper early in the conference, people know you and will come up and chat, and it's a great way to learn. I found the first paper I did here was, I learned more than I put into the paper by far. And so it's a very, very worthwhile endeavor, even though there's this editor at the other end of the chain.
I'm going to try and make sure that what you prepare to present here is as good as it can be.
That's right. It's all with love, right?
I think so.
I think so, yeah. When you see a paper all redlined, though, it's kind of... I'm just kidding, but I know that you put out a really good product.
Well, there's a lot of papers that arrive to my desk, if you will, that are in pretty darn good shape.
Yeah.
There's a lot of folks, male and female. There are a lot of folks that are preparing very, very good communications, And with those papers, my job's easy.
Right, right.
And I always look forward to seeing them.
That's good. That's good. All right, cool. Well, hopefully we'll, in our audience is I know the call for papers for next year's RAMS has already been published.
Yes.
And I'll hook a link to that in the show notes. But it's a long process. I think call for papers are due like in March, if I remember right.
Mid-March, the abstracts come in. Paper selection takes place in early May.
Early May, June.
And then paper production processes for the authors and the referees continue through the summer. And final paper submission is by about the 1st of October.
1st of October.
And then I spend all of October and November putting the proceedings together.
Which is a huge task. There's a lot of papers.
Well, it's a pretty demanding responsibility, that's true.
Well, I sure appreciate you taking the effort to make it all work, because it shows. It's a really good conference and good proceedings. Yeah. And a pleasure chatting with you. I know I've been on the other end of your pen a few times, and like you said, it does make it better. So.
Well, you know, one of the reasons it's good, and I shouldn't take too much credit, because one of the reasons it is good is because the authors are preparing good papers. The classic quote that I used in my quality control class that I got from my grandmother is, you can't make a silk purse out of a sow's ear.
That's right.
So the raw material that comes to me is already good.
Right.
All I'm doing is trying to help make it communicate as effectively as possible.
Well, we thank you for that. All right. And I should ask, is there a site or a place that people can get in touch with you, or should I just forward comments to you if we get any? Questions?
Simply go to Virginia Tech, and I'm on the Virginia Tech website there.
Okay.
You can find me through the Industrial Engineering Department, Industrial Systems Engineering at Virginia Tech.
Okay.
You can communicate me through there.
All right, so I'll link to that, so if people want to track you down and discuss some of this stuff with you, they can contact you directly.
Sure.
And that'd be great.
Fine, yeah.
All right, well, appreciate it, Joel.
You're welcome.
Thank you.